All right, so we've got a solar flare watch in effect. We'll be talking about how earthquake droughts end in earthquakes. Further analysis of sunspot 2842, the most likely location of an M-class flare. New sunspot rising in the northeast. That's an alpha class so far. And a new sunspot group forming ahead of that sunspot as well. Right there we see Umbre. So we're going to have 4 named active sunspot regions here by the end of the day if activity continues as it is. This large area over here is definitely going to get a name. And we see significant Umbre already. Here's the 171 angstrom view now that we showed you the colorized magnetogram. We also saw a radio burst, and there was no coronal mass ejection associated with that, otherwise our patrons would have already known. And let's zoom in a little bit on the equator here. Great view there of the closest star in ionized iron spectra. And here's ionized helium. And you can see some activity actually from this. This is likely where the radio burst, 245 megahertz radio burst came from. And there's the full disk view in that wavelength, 304 angstroms from the Solar Dynamics Observatory. Here's a diagram of the solar system. If you're wondering where things are located, that's where they are. And we've advanced that 1 week. There's where things will be a week from now. The radio flux has come up to 80 solar flux units. And here's a 1-year chart of the 10.7 centimeter radio flux. The black line there, the red line below it, is the sunspot number. And we can expect both of these to continue to increase here as cycle 25 progresses. No space weather storms forecasted here, no kind of geomagnetic unrest or geomagnetic storm conditions expected by NOAA or us. Let's talk seismicity. Here's a 90-day chart of Earth's earthquakes. And earthquake droughts end in large earthquakes, as you can see from the previous years. Especially this earthquake drought in 2018. It was an exceedingly long earthquake drought. Anyway, we're currently in an earthquake drought. And coincidentally, droughts of water are also associated with earthquakes. It probably has something to do with underground aquifers and things like gravity. But in any case, if you're in an earthquake-prone zone, please have a plan. Again, earthquake droughts end in large earthquakes. Historically speaking, I don't think we're going to go into an earthquake-free time in earthly history. If you think so, leave us a comment, let us know. And we're just scrolling up the list here. There was a deep quake near Indonesia at a 4.9 magnitude. And it looks like the largest quake of the past 24 was a 5.4 at Iran. Probably caused some damage there north of Saudi Arabia. Pitcairn Island region also saw a 5.1. So pretty light when it comes to earthquakes. There was also a 4.2 there on New Zealand. That one at depth also, 112 kilometers estimated depth for that. Chile saw a deep quake, as well as Bolivia. Those both 4.5 magnitudes. One over 100 kilometers, one over 250 kilometers. And those taking place about a half hour apart there, and pretty close to each other as well. Around the Andes. And a very deep quake here south of the Fiji Islands at a 4.6 magnitude. Also, Indonesia saw a 5.2 magnitude quake at 160 kilometers estimated depth. Another rather deep quake. Here's one south of southern portion of Peru there, a 4.7 magnitude. And another 4.2 at extreme depth near Fiji. 525 kilometers estimated depth. Let's check volcanism now that we did seismicity. Subanose Jima, the volcano in the Ryukyu Islands, is erupting and producing an 8,000-foot plume of volcanic ash. Dukono exploding, 7,000-foot plume of ash from it over the Isle of Halmahera. Fuego in Guatemala also exploding, 15,000-foot ash plume over the Central American country. Nevado del Ruiz producing a 19,000-foot ash plume over Colombia as it explodes. Sabancaya in Peru exploding, 24,000-foot plume of ash from that. Nevados de Chilean following suit with explosive activity, producing a 14,000-foot plume of ash. Please don't pole vault that caldera. It could be what we call unhealthful. We prefer for you to be healthful at smashomash.com. And we've even got more on that and things like longevity and autophagy later in the video. So stay tuned for that. So do not pole vault the caldera. And this public service message brought to you by Smash staff and I over at smashomash.com. Please give Smash staff a raise and pick up some merch. She needs one. Let's look at some X-ray data here from the GOES 16's sun-facing suite of instruments. No major flares here over the past 3 days. One just was right on the line between B and C class. And it looks like it was actually a B class from the way the latest looks. You know what? I think that actually was a C class. It looks like it just barely got into the C range there. But in any case, there's the 3-day chart. Proton flux not showing any spikes. No surprise there. No coronal mass ejections headed Earth's way either. Wild spike here recently happened in the GOES magnetometer. Check it out. If you're wondering what these N's and M's mean, that's noon and midnight local time for the GOES 16. Some wild spikes. Could have been a sheet of plasma. Could have been a coronal hole plasma wind stream there that sort of swung past and caused that magnetometer reading. Could have been various things. I won't conjecture any more about it. But a big wild swing there, and it actually caused some geomagnetic activity on the Earth. We got up to a KP of 3. We'll cover it in a minute. First, let's take a look at the details of the heliospheric current sheet and its polarity. Here, North Pole polarity shown in green, South Pole polarity shown in red. And Earth is in a North Pole current sheet. And we could see this suddenly change in the next couple of days. Don't be surprised to see a South Pole current sheet on this data set when we cover it tomorrow. Here's a line of sight ecliptic plane field plot. The same data from the perspective of Earth instead of the top view. A great three-dimensional view of the heliospheric current sheet and its polarity. And here's a line of sight coronal hole plot showing the sun's B field in blue and coronal holes in North Pole green, South Pole red. Keep in mind the data is an hour and 25 minutes old and can change with basically no warning. We do the warnings. That's why we have a channel. So again, there is a solar flare watch in effect. Don't be surprised to see an M-class flare come out of sunspot 2842. It's this one up here. And this is some different data here from the Integrated Space Weather Analysis Center. You can look it up yourself at the ISWA, Integrated Space Weather Analysis Center. Also the coronal holes plot there, not showing very well-defined coronal holes. And we just brought this up because of the solar flare watch in effect. And there's that KP3 that we saw induced by that sudden swing in magnetism. Otherwise, quite geomagnetic calm conditions. And you can expect to see this subside. No major signals in the real-time solar wind data. Here it is. We did see the density just recently drop off. So the density suddenly went from 17.4 protons per cubic centimeter all the way down to 3 protons per cubic centimeter. A precipitous dip in solar wind density. Also, we saw the BTBZ. BZ moved into north territory. and the BT went up as well. So some strong North Pole magnetism there. Phi angle also shifted. That is essentially the spin moment of the incoming solar plasma. Current conditions are about 3.5 protons per cubic centimeter for the solar wind density, solar wind speed 368 kilometers per second. Moving on to geospace magnetosphere movies, here's the magnetohydrodynamic pressure out to about 12 Earth diameters. And we can expect to see the pressure drop off here. This is 4 hours of data courtesy University of Michigan based on the space weather modeling framework, and the graphics here are the scale of nanopascal from 0 to 1.5 nanopascal magnetohydrodynamic pressure. If you want to read more about it, go to the Geospace Magnetosphere Movies page, click on the Details tab, and click on Space Weather Modeling Framework. A lot of variables go into this data set, and since it refreshed, we're letting it play all the way through. And there you can see the pressure suddenly drop off with that sudden reduction in the solar wind density. Here's the ground magnetic perturbations, and we can expect to see something similar with perturbations on planet Earth. Ground magnetic perturbations are known as geospace delta B, and in science, when you see the variable delta, that means change in whatever you're looking at. This scale is in nanotesla. Magnetic flux density, not magnetohydrodynamic pressure. And by the way, thanks for everybody tuning into the videos. Please tell your friends and foes about our channel. And most of our content is on YouTube, youtube.com/smAsho. Check our playlists, youtube.com/smAsho/playlists. We're also on Twitch, thanks to our followers over there. No Twitch video today. They got a great mobile app and the best live streaming platform. Have you seen our 500 subscriber BitChute special? Yeah, go check it out. bitchute.com/smAsho, exclusive content over there. And yesterday we had some deep thoughts, so check out that video. You can find all of our videos at smashomash.com, at youtube.com/smashomash/videos. That's youtube.com/smashomash/videos. Are you wondering what the deep thoughts were?
Deep thoughts.
Well, I can't tell you. You've got to watch the video. And we've got a cosmology segment today. We're going to integrate it into the daily space weather video. Space, a frontier. These are the voyages of the YouTube channel smAsho, our continuing mission to provide objective and relevant data, to seek out new channels and make fun of them, to boldly go where no one has macked on other channels before. So check out zooniverse.org. The Galaxy Zoo is back. They've uploaded more galaxies into it. If you want to go classify galaxies, it's pretty easy. It's the largest citizen science project in the world. Just go to zooniverse.org, go to the space section, and you'll find the Galaxy Zoo. I'm going to classify one for you just so you know what goes into it. So here's a partially edge-on disk, and we see features, so we select features. Next. It is not really an edge-on disk. It's actually something else. It's not quite edge-on, as we don't see quite the distinctive cigar shape there. I'm going to say no bar for this one. No spiral arm pattern visible. It does certainly have a bulge. We're going to say moderate. It does not appear to be merging or disturbed, so we pick none. And then we can see some evidence of a dust lane. And a bit of a ring sort of a scenario happening there. And that's it. That galaxy is classified. Here's the next one. Again, zooniverse.org, the world's largest citizen science project. Go classify galaxies. Computers are unable to do this work. We need humans. Check out the astronomy picture of the day at apod.nasa.gov. apod.nasa.gov. And it's entitled Framed by Trees, a Window to the Galaxy by Will Godward. A great view of the Milky Way galaxy framed by some redwoods, I believe it is. And again, please give Smash staff a raise by heading to our shops. Here are the designs on the Redbubble shop. This is the smAsho merch shop. 7 of them. And here's our other shop, one of our other shops. This is the smAsho store. Are you safe yet? Are the videos that you view on YouTube helping to make you safe, or are they making you more endangered? Let us know in the comments. And again, give Smash staff a raise by picking up some merch. We invite you to Mansa, Make America Not Suck Again, because it's up to you, not the government. You can find the links there. The Redbubble shop is smAsho merch. The other one is the smAsho store. There's even another one called the Smash store, which we won't even mention in this video. You can also find our social media there on our homepage, smashomash.org. We'll redirect you to smashomash.com. And welcome to the Neo Renaissance. Let's talk more about it. We've also got a forum, which you can link there. That link is right there, the smAsho forum. It's free. And we've put up a post about autophagy. If you don't know what it is, go read smashomash.com/forum. And why are we talking about this in a cosmology segment? Well, because it's part of our mission and because you're from space. So our mission, you can go read about it if you like at smashomash.com/forum/mission, smashomash.com/forum/mission. Number 5 is to publish scientific papers in a multidisciplinary manner, including sciences such as spectroscopy, chemistry, astrophysics, health and wellness, longevity, cosmology, and biology. Today's random number is 52, which coincides with galaxy NGC 526, which is a Seyfert 1.5 type of active galactic nucleus. Here are the X-ray transient outputs from it. Up in the upper right, you can see the 16-year chart. It did have a strong outburst here in 2018, it looks like. And in the lower left, you can see the 30-day chart, the X-ray outputs of galaxy NGC 526. Let's take a look at it in a couple wavelengths. Here it is in X-ray. And it's quite bright here in X-ray. And let's move down the electromagnetic spectrum to UV light. You can see how vastly differently it looks in UV light. And the UV light gives us some insight into the internal plasma structures. A little bit of additional detail from that galaxy in UV. How about in colored? This is the optical bands. There it is in color, and it looks like it's a double galaxy. So it's perhaps in the process of merging or something like this. Perhaps explaining some of the oblong appearance, as we see 2 significant ultraviolet signatures there. Perhaps it is a double core galaxy. And here it is in infrared as well. And these are probably somehow interacting, maybe in the early stages of a merge, or maybe swinging past each other. Anyway, that data is from the 2MASS. And again, that's galaxy NGC 526, which coincides with number 52 at the Neil Gehrels Swift-Bat X-ray Observatory. Go have a look for yourself if you like. And that's today's cosmology segment. And while we integrated today's into the Daily Space Weather videos, there are over 200 other cosmology segments on the channel. YouTube.com/smashomash/playlists for the full cosmology segment playlist. Let's check the electron scenario around planet Earth. We see some minor charging hazards here over places like the Caribbean, Mexico, and the Central Pacific. North of the equator there, a little bit of charging hazards induced by the electronic content around planet Earth. Here's a 1-year chart of the electron flux. Those electrons are moving at very high speeds. That's why we call them the greater than 2 mega electron volt electron fluents. They're relativistic. They're traveling at a significant percentage of light speed. Here's the 3-day chart of those. Once again, the N's and M's refer to noon and midnight local time for the GOES 16. Here's the forecast model, and NOAA expecting a dip in the electron flux. I have no reason to argue with that or refute it. The green boxes are the forecast. And here's the diagram of the Van Allen belts. Feel free to pause the video. Distances are in miles for that. And here's the total electron content forecast, showing you the entire air column in terms of electron density. So this will give you an idea where GPS errors are likely to happen. Let's allow it to play through a second time. It doesn't look particularly anomalous, and we see more organized electron belts when we see more moderate levels. When we see very low levels of electron flux, like coronal hole-induced low electron flux levels, we see the most anomalous electron bands. Next, we're going to show you the ionosphere, an animated ionogram of the F ionosphere layer located here at 300 kilometers of altitude. And just let that reload real quick. There we go. So it's a full day of data here, 2 hours per second. And you're looking at vibrational frequency. Each blob corresponds to a difference of 1 million vibrations per second. So 6 million vibrations per second, 7 million vibrations per second, otherwise known as megahertz. The ionospheric anomalies over North America have subsided big time. Ionosphere looking much more normal today. Here's the latest image coming through at 9 o'clock Universal Time. Nothing to write home about there. By the way, check our meteorology segment if you haven't. We did a meteorology segment today separate. And again, it was not streamed live to Twitch. It was a separate recorded video. So let's do bonus features. But first, let's thank our patrons. Thanks, patrons. You are officially producers of these videos. So, patreon.com/smAsho if you'd like to be on our credit crawl. If you'd like to be off our credit crawl, just send us an email or something like that. Also, our top-tier patrons have the option of obtaining a @smashomash.com email address. If you like, just drop us a line. We will hook up our top 2 tiers, the gold member patrons and condensed matter to the 9th power patrons, with their own @smashomash.com email address. And again, don't forget to check out our meteorology segment from today. Here's Lermonth, Australia's ground-based solar observatory data. It's hydrogen alpha. You're looking at the spectra of hydrogen. Look at all the prominences up here associated with this new sunspot. That will get a name today, by the way. And again, don't forget about the solar flare watch. Don't be surprised to see an M-class flare come out of sunspot 2842. Lots of filaments here as well. You can see filaments down here and filaments in the north. Here's the latest data from the SDO intensitygram. You can see this sunspot is still beta class. It still does harbor energy for maybe C-class flares. This one up here is quite magnetically complex. Sunspot 2842 certainly capable of producing M-class flares. And here's the new one. Looks like it's only alpha class. And this sunspot in front of it, this is likely to get a name as well. So we're going to have 2 new named sunspot groups today. Expect to see the radio flux come up as well. Here's the magnetic environment around sunspot 2842. Again, it's quite complex. And it's the main source of our solar flare watch. Although we could see a flare come out of this one too. It is quite close to the limb. Here's more bonus features. It's the NASA GOES SUVI thematic map. There is a small crown prominence up here, you may notice. Right up here. Actually, a couple of crown prominences there. And don't worry, folks, we haven't seen Nibiru make its way out of one of the solar polar fields and try to destroy all life on Earth yet. Thank goodness. I was very, very concerned. Oh my God. Pardon my sarcasm. And here's one more animated view from the SDO. It's the 171 angstroms and colorized magnetogram composite imagery. And thanks for tuning in, viewers. Remember, stare at the sun, attempt to understand the physics. Don't drink, and if you do, don't drive. Seriously, don't drive. No matter how much I like you, I don't want to see you on the road, and I prefer low traffic, so cheers. And we'll talk to you soon. May that solar wind be at your back. Please press like, subscribe, and share on your social media. This broadcast brought to you by Smash News Network, Least Busted, Name and News.